Quiz 1, answers. We'll bring in my favorite student, good old Anne. A book is sitting on a level desk. Gotcha. I'm visualizing. In fact, you know what? I'm looking at my binder. If I was a student, that's a book sitting on a level desk. Which of the following statements are true? There are no forces acting on the book since it's not accelerating. True or false? False. The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force on the book. Huh? I think we're saying, yeah, you know what? I think that's true. We're not on a slant or an angle or a tilt, and it doesn't mention any other forces. The net force is equal to 0. Absolutely. That's why it's not accelerating. Not that there's no force. It's not accelerating because the net force is 0. That is Newton's first law of motion. Friction force is what's holding the book on the desk. If your tables are level and they were made of ice, could the book still sit on the table? I don't think friction's what's holding it on the desk. So false, true, true, false. Half mark for each of those. So that question there is out of 2. More than one mass. Okay. Find the acceleration of the entire system. Well, I'm going to say m1g normal force number 1. No friction, it says. Tension. m2g normal force number 2. Tension. And I'll put an arrow there to remind myself I got an applied force. Check. Oh, treat it like one mass. I'm going to write an equation for the entire system. Who's winning? Well, if this is on ice, it has to be accelerating to the right because you're pulling it. So I'm going to say winner. And then I'm going to have minus loser plus winner equals the mass of both times A. Did you have a good weekend? I had a relaxing weekend. Do you know why I had a relaxing weekend? Losing tension. Always good to lose tension. And in fact, I'm even on this line going to get the A by itself. I think to get the A by itself, I'm going to divide by the bracket. I think my next line, I'm actually going to go A equals 24 divided by 8 plus 12. 8 plus 12 is 20. This is 24 divided by 20, divided by 4, divided by 4. It's going to be 1.2? Yeah. And it's the acceleration, meters per second squared. By the way, probably if you're really a nerd like me, you've noticed for most of this unit, although acceleration is a vector, I've been sloppy. I'm only asking you to find the magnitude because we've got things, especially with the Atwood machine, you got things moving in different directions. Really, I should always hear Justin be saying, find the magnitude of the acceleration. I noticed that long after I typed all these, and I'm too lazy to go back and fix it, but you guys have hopefully figured it out anyways, that when I say in this unit, find the acceleration, I just want the magnitude. 2 marks, 2 out of 2 if you got that. Otherwise, I would probably go something like this. I would give you 1 mark for the equation. I would give you a half mark for A equals 24 divided by both masses, and a half mark for the answer. Find the tension. I'm going to find the tension from mass 1. If I found the tension from mass 1, I'd have winner equals M1A. It's going to be 8 times 1.2. 8 times 1 is 8. 8 times 0.2 is 1.6. So it's going to be 8 plus 1.6, or 9.6 newtons. Is that right, I hope? Did anybody find it using mass 2? I can do it that way, too. You'll get the same answer. That's why I drew a line down the middle. Do you want me to do it with mass? Everyone use mass 1? Oh, good for you. Clever humans. Really, I gave 2 marks for that? Well, you know what? I guess, yeah, because I'd probably go 1 mark for that. I'd probably go half mark for the numbers and a half mark for the answer. But again, if you got the right answer, 2 out of 2. You may have noticed, and I may have said this before, Lewis, but you're teenagers, it's worth repeating. In my homework, I will try and push the envelope. I'll try and see how much I can do up here because I want to become an expert. Quizzes and tests, I don't take any shortcuts. I really want to write every step because I don't want to make a dumb mistake, right? Number 3, find the acceleration if there's a mu. What's mu? I don't know. What's mu with you? 0.12, right? So there's going to be a friction force, number 1. And there's going to be a friction force, number 2. In fact, my equation now is going to be, oh, and I should also then say, apparently that's 50. Why 50? Because apparently 24 newtons wasn't enough to get it moving when I first made up the numbers. Oops. So who's winning? 50. Who's losing? I have minus tension, minus friction force 2, and then I have plus tension, minus friction force 1. That equals M1 plus M2 times A. Once again, I get to relax. I get friction is mu times normal force number 2. Friction is mu times normal force number 1. And Colin, I'm going to be bold on this line. I'm already going to get the A by itself because I figure since it's the last step, I can keep track of that. Friction is mu times normal force number 2. I don't know normal force number 2. Oh, but look, 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 look. I know the force is the same size as normal force number 2. And I don't know normal force 1. But look, 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 look. I know another force is the same size as normal force number 1. Hopefully I'll be able to fit this in here. You know what? I think I'm going to have to do it all down here. I think I'm going to get 50 minus mu M2G minus mu M1G all over M1 plus M2. 50, boy, am I going to be able to fit this in, Mr. Dewick? It's going to be, I know what I can do. I need more room. Like that. 50 minus 0.12. Mass 2 was 12. Yeah. Times 9.8 minus 0.12. Barely going to fit this in. 8. Oops, I'm going over the edge. Times 9.8. I've been going over the edge for a while. All over 20. Do this one in your head, Mr. Dewick? Well, maybe. Because it's going to be a 20 times 9.8 is going to be 196 times 0.12 is going to be 19.6 plus 3 points. So it's no, I'm rounding out. I could get the top okay. If I got the top, dividing by 20, that's dividing by 10 and then dividing by 2. I should have been able to do that in my head. That's a Monday morning. I'm allowed 50 minus 0.12 times 12 times 9.8. I mean, I know by the way, I know the answer is less than 1.2 meters per second squared because it's got to be smaller than the previous question because now there's friction, right? So there's a built-in error check. Oh, no, because I bumped up the force. You're right, Dewick. I bumped up the force. Sheesh. I have 0.98? I typed 0.98? Oh, I typed 0.98. Minus 0.12 times 8 times... You know why? By the way, that's why having a good calculator that with a multi-line display is so useful. I'm just saying. It's for situations like that. Do you get 1.324? 1.32, I'll go to 3 sig figs. I'd give you 3 out of 3 for that. Otherwise, I'd probably go 1 whole mark if I saw the main equation. And then I'd probably go 1 whole mark if I saw that. 1 mark for the answer or something like that along the way. But again, 3 out of 3 if you got the right answer. Then find the tension between the two masses. I'm going to use mass 1. In mass 1, I think it's tension minus friction force 1 equals M1A. Tension is going to be M1A plus friction force 1. Tension is going to be M1A plus mu times normal force number 1. I don't know normal force number 1. Oh, but look. I know the force the same size as normal force number 1. It's going to be M1G. Tension is going to be 8 times 1.32, and I'll carry the extra sig fig 4 plus 0.12 times 8 times 9.8. 8 times answer button plus 0.12 times 8 times 9.8. Do you all get a tension? 20? Is that right? Yeah. Worked out evenly? Oh, that's a fluke. Kind of nice, though. 20 what? Newtons. If you got the acceleration incorrect, but then you went 8 times your acceleration plus 0.12 times 8 times 9. I'll give you 2 out of 2 for this. Good question. And that's always the case for the entire year. Elevators. This is a job for a free body diagram. In part A, first of all, it says a person is standing on a scale that reads the normal force in newtons. So find the scale reading, find the normal force in newtons. If I had wanted to, I could have said find it in kilograms. You would just divide whatever answer you got in newtons by 9.8. That's the actual conversion factor. Okay, anyways, up, gravity, up, normal force is winning. So here, my equation is going to be normal minus mg equals ma. My equation is going to be normal force equals ma plus mg. It's going to be 60 times 1.2 plus 60 times 9.8. This one I can do in my head because 1.2 and 9.8 is 660 newtons. Is that right? Yes? No? Yes? Yeah? Okay. 2 marks. I would give you 1 mark for that, half mark for that, and a half mark for the answer, but 2 out of 2 if you got the right answer. Downwards. And you can see in my free body diagrams, I really, Lewis, tend to exaggerate winners and losers because that's what I want to get correct. Gravity's winning. In fact, it looks like I drew gravity bigger than the previous one. I'm not saying gravity's gotten bigger. I just want to make sure that I write this. Gravity minus normal force equals ma. I want to get the normal force by itself. Hopefully you're comfortable with this little dance where we plus that whilst at the same time subtracting that over. We get mg minus ma equals Fn. The normal force ends up being m60, 9.8, minus 60 times 2.25. $453 newtons, because we're doing normal force. In other words, in part A, because normally their normal force in both of these would be 60 times 9.8, 588 newtons. In part A, they feel heavier. In part B, they feel lighter. Hopefully you've noticed that on an express elevator especially. C, keyword, constant velocity. Now, many of you probably leaped to a conclusion, but if you did not, you might have said, got gravity down. Jake, you might have said, since it's moving upwards, normal force is the winner. Now it's a constant velocity that's going to change things. But even if you didn't catch that, as long as you caught the up, because you would have gone like this, winner minus loser equals ma, you would have said, but constant velocity, what is a if you're at a constant velocity? Which means, really, you have this. It's a tie. And that's why I happened to type that in 30 seconds ago, because I knew this was coming. 588 newtons. Again, this is where Einstein came along and said, well, if you get the same answer when you're moving at a constant speed or when you're at rest, maybe it is all relative. Maybe there's no difference. One of Einstein's postulates, hypotheses in his theory of special relativity was there's no way to prove that something is moving at a constant speed or at rest. There's no experiment in the universe that can be done. You'll get the same results on your experiments if you're moving at a constant speed. Sorry, I should be careful. Constant velocity, because your direction can't change either, as you will at rest. D. If you're in free fall, what's a scale going to read? I think 0. Let's prove it. What are the forces acting on this object? Get the obvious one. Gravity. What else? Maybe there is a normal force. I'm not sure. I'll draw it. I definitely know it's losing because we're accelerating downwards. So I would say, who's winning? Gravity. Who's losing? Normal force. That equals ma. Once again, we would do our little dance. We'll have mg minus ma equals Fm. We'll have 60 times 9.8 minus 60. What's the acceleration? Also 9.8. I can do this in my head. This does work out to 0 newtons. And this is now, if we come full circle, am I weightless? Well, no, gravity is still there. We call this apparent weightlessness. This is what you pay for in the amusement park ride. We can't get rid of gravity, but we sure can muck around with the normal force, and you'll pay money for that. As usual, 1 mark, half mark, half mark. But if you got the right answer, 2 out of 2. Could you give yourself a lovely score, please, out of 19? And if you need to come lawyer with me, now is the time. Last day, we looked at the inclined plane, and I threw a whole bunch of questions at you. And normally I would start out saying, hey, any questions from the homework? But if you look very closely, Lesson 7 is Advanced Inclines. It's a continuation. I'm going to gamble that if I start this and do nastier inclined questions, that it might answer some of your questions from the homework. But then what's going to happen is I will still take questions from it next class. Or you look like you had a specific question? Or I'll do it later on in class. Okay? That's the plan. It's a gamble, I know. So Lesson 7 is called Advanced Inclines. I'm gambling that Advanced Inclines might help make clear some of the inclines from last day. We'll see. So here's a nice question. I see a ramp right away. I'm thinking components. I'm going to make gravity parallel and perpendicular. How much force is required to pull this mass up the frictionless ramp at constant speed? You know what? There's a key phrase that I would underline, which is the key to this question. It's the last 3 words. Because, Ty, what does that tell me? Constant speed. I'll make a little note. Okay. Any thoughts on how I'm going to start this? Probably the same. Yeah, okay. But rather than draw a free body diagram in a separate location, did they give me a lovely picture? I'll label the forces on my diagram. What are the forces acting on this 7-kilogram block? Get the obvious one. Okay. Draw it nice and big. Put the mg on the same side as the pointy part, because otherwise it ends up inside your triangle. Before you go further, say to yourself, angles, yes, I'm going to break gravity up into its components. You know what? I'm going to totally change colors. I'm going to go mg in blue, because I like to do the components in red, because for some reason that helps emphasize that they're not really there. Okay. What else? Is this block sinking into the ground like quicksand? Is it flying off the ramp like Superman? So there has to be another force, but it's perpendicular. How big? About that big, yeah? The same size as mg parallel. There's my normal force. What else? There's a rope. You could have drawn it as a separate arrow, but since I had a lovely rope there, I just put an arrow on there. Okay. If I did draw tension in as a separate arrow, how long would that arrow end up being in this question? Exactly the same as what? Parallel. So maybe I might even do that, because that's a good teaching little moment. Right about there. Tension. Who's winning? It's a tie. But which way is this mass moving? You know what? So we don't get confused, let's let up be the winner, because that way winner is at least the same direction that we're moving, since it's a tie. So I'm going to go like this. Tension is the winner, and I guess it would be minus mg parallel. That's the loser. and that equals ma. But Tyler, what did you say? Constant speed means what? So really, what does the whole right side, what's m times 0? So the whole right side works out to 0. So if it's okay, I'm going to just plus that to that side, and I'll get, because this question wanted me to find tension, apparently tension is going to be mg parallel, which is which trig function? Sine. Again, I gave you the stupid mg2 lines as sine, but hopefully, Rob, even if you freeze, or you know what? We said this angle and this angle are the same, opposite hypotenuse, there's your sine. So this is going to be mg sine theta. It's going to be m7 g 9.8 sine 40. .1 newtons, because it's tension. Is that okay, Jake? Thumbs up. I'll be honest, I wouldn't consider that very advanced inclines. You know what would be more interesting? How about let's bring a little friction to the table. So now it says, suppose mu equals 0.65. That's a fairly big coefficient of friction. Tension's going to get bigger. How much force is required now? Let's go back to our free body diagram, or our labeling the forces. We need to add friction. Which way would friction be? I got to be fussy now, because now we have multiple downs. So just down the ramp. So you're saying, I'll do it in black so that you can kind of tell I added it afterwards. Friction. What's my equation going to be now? Well, there's still going to be a tie, but which way are we moving up? So I'm going to let up be winner. I think my equation is going to look like this. Tension minus mg parallel minus friction equals. Tyler, I took a gamble and just put the 0 there instead of putting ma, saying that you would remember that constant speed means a is 0. How would I get the t by itself? Good. So if I hear you correctly, tension is going to be mg parallel plus friction, which is going to be mg parallel plus friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. I know another force on my diagram that's the same size as the normal force. Which one? Don't be saying no mg, because it ain't. Mg perpendicular. So I'm going to get this. Tension equals mg parallel plus mu mg perpendicular. Now that you've started to wrap your brain around this, common mistakes. Kids get this far, and then they're so proud. I've got the equation. And you should be proud. And they say, oh, mg2 lines is sine. And then they go mu m, and then they go g perpendicular is cos. Of course it is. I see this. They're so thrilled to get the sine and the cos that somewhere along the way they forget the g. So I see that happen quite often. Don't do that. Or they're so thrilled to get the trig functions, the mu often vanishes as well, because they're so, I want to get the trig functions. Can I just say, Kate, ramp up your level of paranoia and your level of carefulness right on this stage? This seems to be when the most mistakes pop in. Time and time again, I'll see this equation, lovely, beautiful, and correct, and then sloppiness as we start actually breaking it down further. But now it is plug and chug. What was the mass? 7? Yeah. 7. Or on this next line, they'll forget to drop the g's down. I'll see the 7 and the trig function. sine 40 plus 0.65 times 7 times 9.8 cos 40. Thankfully, Rob, I have a good calculator that lets me do this all in one fell swoop, and I can see if I make any typos. Colin, you got one of those too? Nice calculator, lets you see if you know. Doesn't it feel nice? Superior even? I think so. And I get 78.3. Anyone else? Yeah? Yeah? Good for you. 78.3 newtons. Oh, hey, what if instead of at a constant speed, what if I had told you what I wanted it to be accelerating at? Well, then, Ty, this wouldn't have been 0. This would have been MA. I still would have plussed these over. I just have an MA at the front here. Okay. Doable. Ooh, what if I'd given you the tension? I like this question. And instead, I didn't give you the coefficient of friction. What if I said, what does mu have to be? You would get to this line right here, but you know what you would get by itself? The mu. You would have left this here, probably would have plus friction over, and then you would have said, okay, I'll divide everything at the end by the normal force. I don't know the normal force. Oh, but look. So we can get, as far as I'm concerned, Lewis, any of these sub things by itself. Oh, I could even actually ask you to find the mass. Now, there would be more than one mass, more than one m. It would be wonderful if there's a grade 9 mathematical operation that I could reach into my back pocket. I get the m's all to one side. I'd factor out a GCF to turn it from 2 m's into 1 m. All doable. Example. Next one. Ooh, an Atwood machine, but with a tilt. Okay. 2 objects are connected as shown. Mass 1 is 12 kilograms, check. Sits on a horizontal surface that has a coefficient of friction of 0.17, gotcha. Mass 2 is 9.8 kilograms, okay. And it sits on a frictionless surface at an angle of 42 degrees, gotcha. Find the acceleration of the system. First of all, is it possible for this to be accelerating to the left? No. It's either going to be friction is so big that it's at rest. If that's the case, when I try and solve for A, I'll get a negative answer. Oops, wrong winner. Or it's accelerating to the right. Okay. Any thoughts? Label the forces? Sure, let's do that. I can do that. Mass 1, what are the forces acting on it? Get the obvious one. Normal force number 1, it's not sinking into the ground like quicksand, it's not flying into the air like Superman. Hey, there's a rope. Woohoo! Tension. Friction? To the left. Friction force number 1, to go with mass number 1. What are the forces acting on the second mass? Get the obvious one. Gravity, you say? Oh. Angles, slanty. Before I go further, let's break gravity up into its components. I'm going to break it up into mg perpendicular and mg parallel, where that's a lovely right angle. What else? It's on a surface. It's not sinking into the ramp like quicksand. It's not flying into the air like Superman. There's got to be a normal force. How big is the normal force going to be? About that big. What else? Anything else? Friction, too, as well. Which way? Up the hill? Oh, mass 2, to make it easy, is friction. Now, by the way, if I had included friction on mass 2, mu times the normal force. I don't know. Look. I know another force the same size. Doable. Longer. Could I call it tougher? I call it longer. Okay. Frictionless. Well, that was nice of me. It's funny because I was thinking as I was going over this, boy, I really packed a lot into here. And then I went, no, okay. So, who's winning? Which force? That's not a force, that's a mass. Which specific force on my diagram is winning? mg parallel. Anything that ends up pointing this way eventually is going to be winner plus. Everything else is going to be loser minus. So my equation is going to look like this. Winner. Then I run into a loser tension. Oh, then I run into a winner tension. Then I run into a loser friction force number 1. Have I written forces from more than one mass? Well, then on the right-hand side, I better have more than one mass. Colin's yawning. You know why? Because he's relaxed. Losing tension on cue. Okay. By the way, what are we trying to find? Can I be bold and on my next line already get the A by itself? How would I do that? I would divide by the big bracket. So I'm going to be really, really adventurous, and I'm going to say, okay, it's all going to be divided by M1 plus M2, and I'm going to have mg parallel. Now, in your homework, I would have no problem if you were already tempted to say, oh, mg, and instead of writing parallel two line and go straight to sine. In our notes, we'll show the substitution so that when you're studying, we know our reasoning, minus friction 1. This is going to be mg parallel. Oh, hang on. M2g parallel. I really should have called this M2, M2, and M2 since there's more than one mass, isn't there? So it's going to be M2g sine theta minus mu. Oh, friction is mu times the normal force. I don't know the normal force. Oh, but look, 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 look. I don't know the force the same size as the normal force. What's the normal force for mass 1? The same as. It is the same as M1g because we're flat. This was physics 11. So I can go M1g, and that's all going to be over M1 plus M2. Let's plug in numbers. What did I say? Mass 2, 9.8 and 12. Okay. 9.8 times 9.8 sine. Okay, I'm not going to fit this in, Mr. Dewitt. Let's try this again. Equal. Oh. Let's go a different color. Equals 9.8 times 9.8 sine 42 minus, what did I say mu was? 0.17 times, and mass 1 is 12, times 9.8, all divided by 12 plus 9.8. More than one thing on the top, better put it in brackets. More than one thing in the bottom, better put it in brackets. 9.8. Ha! I'm going to be clever. Instead of writing 9.8 times 9.8, can I just do that? It's a fluke that they happen to be the same number. Please don't think that the normal equation has a squared in it. It's just I'm lazy. Sine 42 minus 0.17 times 12 times 9.8. Close bracket off, divided by 12 plus 9.8. You get an acceleration of 2.03. That? Anybody else get that? Because I did a lot of... Yeah? 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 Okay, 2.03 meters per second squared. B says, find the tension. Mass 1 or mass 2? I'd probably use mass 1 because it's flat and I'm better with that. But if I found it with mass 2, it would be mg parallel minus tension equals m2g. I'm going to use mass 1, which is just going to give me tension minus friction 1 equals m1a. Tension is going to be m1a plus friction force number 1. It's going to be 12 times 2.03, although I'm going to use my answer button, plus mu 0.17 times 12 times 9.8. By the way, if you really break this equation down, here's what we're saying. The tension in the rope has to, first of all, create the net force on the missing object and overcome friction. Okay, that makes sense to me. 12 times answer button plus 0.17 times 12 times 9.8. I got a tension of 44.4. I hope. Rob is eagerly looking ahead. What else can, I mean, all I can do now is really add more angles and more hills and more tilts, or, okay, find something more obscure than just the acceleration. Give you the acceleration, and you have to get some other part of the equation by itself. I really can't do much more than that. Or can I? Now we're going to get into good physics versus being lazy. I will show you the good nerdy physics method, and then I will let you know that I tend to be lazy. Example 2 says this. How would you determine the direction this system moves? You know what? First of all, let's label the forces. Little m and big M. What are the forces on little m? I'd have little m, G, and tension. What are the forces on big M? I'd have big M, G, which I would break up into big M, G perpendicular and big M, G parallel. And tension. Oh, there's also going to be a normal force. Good point. I don't know. Hold that. Let's pretend, first of all, this is ice. What's going to happen to the tensions when I write my great big equation every time? You've noticed the trend? So where is the tug of war between? Which two forces are really tugging at each other? What are my possible winners? Either what or what? Yeah.
mg
this one?
small.
Yep.
Or mg big perpendicular.
Which is,
No, parallel.
and parallel is two lines, which is, okay. So how can you tell which direction? mg versus big mg sine theta. Which, even on Rob's calculator, wouldn't be that tough once you've done your free body diagram before you start writing the equation to very quickly crunch and just compare the two numbers. Okay? Now, someone said, what about friction? See, this is the only issue. If little mg, if the hanging mass wins, which way is big M sliding? Up the hill? Which way would friction be? Down the hill. Or, what if big M is heavier and winning? It would be sliding down the hill. Which way would friction be? Up the hill. That I'd have to fix and flip-flop. Although that's a pretty easy fix. I'd scribble out one arrow and put it on the other direction if I guessed wrong. So this is how you can calculate it. Although, I'll be honest, I usually don't bother. I guess. First of all, I know for a fact that if this mass is heavier, it's always going to be the winner because the heavier mass, mg, will always be bigger than mg with a trig function. So if this is 12 kilograms and this is 10 kilograms, I don't even do the math, the 12 is going to be the winner. Or it's not moving at all. It could be friction is so big that it's not moving at all. But if this is like 7 kilograms and this is 13 kilograms, well, really it depends on the angle. If the angle is steeper, the gravitational parallel component's going to be bigger. If the angle is more, in fact, if the angle is flat, then I still know the one hanging down is the winner. So I tend to just, Lewis, guess, and I solve it. And I know I've guessed wrong if I get a negative acceleration. Then I very quickly go back and I say, oh, wrong winner. So every winner becomes a loser. Really, every winner that has a plus sign in front of it, I just put a negative in front of it. Every loser becomes a winner. Every minus, I just make it a plus. Oh, except I might have had friction pointing the wrong way. Honestly, I'll quickly correct it in my diagram, but that's also an easy fix in my equation because the plus or the minus just changes. I'm that lazy. Let me show you what I mean. Example 3 says, find the acceleration of this system. I mean, if the 8 was hanging down and the 5 was on the hill, the 8's got to be the winner because hanging straight down is always going to exert a bigger net force. But if I wanted to, I could crunch this. I could very quickly say 5 times 9.8, that's the net force downwards. And then I could go 8 times 9.8, 2 lines, sine 30. So really, this is winning. Let's guess wrong just for giggles to show you how easy a fix it is. Okay? Let's label our forces. M1G, tension. M2G, M2G perpendicular, sorry. And then M2G parallel. Hey, there's a normal force. I'll call it normal force number 2 to go with mass number 2. Tension. Let's pretend that the 8 kilogram mass, because it's bigger, and Jordan, that might be a reasonable assumption to say, oh, the bigger one's going to be the winner, because it really does depend on the angle. But let's suppose you said that. If this was winning, if the 8 kilogram mass is winning, which way is it accelerating? Up the hill or down the hill? So which way will I point friction? Up. Now, this is wrong, but I'll show you how easy a fix it is. So I'll put friction that way. I would go like this. M2G parallel. That's winner down the hill, even though it's wrong. It's okay. Minus friction force number 2 minus tension. Oh, and then plus tension, because when that hanging tension comes over, it ends up pointing down the ramp. Minus M1G, and that's going to be M1 plus M2 times A. So far, so good. Ty, you relaxed? You should be, right? In fact, let's get the A by itself just for giggles. And it's going to be M2G parallel minus friction is mu times the normal, I don't know the normal force. Oh, but look. I know another force the same size as the normal force. What? Don't say mg. M2G perpendicular. And then I have the minus M1G just drops down like a domino. Let's plug numbers in. M2, 8 times 9.8, parallel, 2 lines, minus, what's mu, 0.05, 8 times 9.8, 2 lines, no, perpendicular. Well, 2 lines is sine. Oh, of course it is, right? And then I have minus M1 G. That whole mess, that's a terrible way to write it, but I'm running out of room and I want to fit it here. And then 5 plus 8, So I'm going to go to my calculator, and I'm going to, now, sorry, Rob, you're the one that's going to be left in the lurch by this, but most of you have heeded me and gotten a half-decent one. I'm going to type in, go to my calculator, I'm going to go 8 times 9.8 sine 30, close off the sine, minus 0.05 times 8 times 9.8 cos 30, close off the cos, minus 5 times 9.8, all divided by 5 plus 8. And here's how I know I've guessed wrong. What did I get for my acceleration? It's pretty obvious. You'd catch it. Ah! I've guessed wrong. Okay. So, who's winning? M1G. Which is the one force that I've drawn wrong? Easy fix. And now I very, very quickly say, this is a winner, so should this one here be negative or positive? Look, 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 look. Winner. I just changed it there. Oh, winner. I just changed it there. Oh, winner. I just changed it there. The tensions still cancel, yes? M2G parallel. M2G two line is a loser? Loser. 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 What about friction? Winner or loser? Oh, you know what? I already, that's convenient. It already happens to, already. In other words, if you have a good calculator, sorry, Rob, you can just do this. Look, you can backspace. Apparently, in front of the 8, I have to insert a negative. And in front of the 5, instead of a subtraction sign, I have to have a, there. I don't care, Addie, which method you use. I'll be honest, the nerd within me tends to find out ahead of time who the winner is. What I am saying is if you miss that and you get a negative acceleration, ding, 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 that should get your attention, Quinn. And it's also a pretty easy fix. There. For most of us. Some people will have to retype the whole thing. Did you also get the same as me? Did you try it? Or if you try retyping the thing from scratch? Now, by the way, Cade, I mean, the order that we've written things is a bit weird, a bit different, but it's right. So I'm good with it. Okay. I get an acceleration of, 0.493? Find the tension. Which mass would be, says find the tension. Which mass would we use to find the tension? I'd use the mass 1, the 5 kilogram, no components or anything. Who's winning? Oh, now we know tension is winning. Kind of convenient. So find the tension. Tension minus M1G equals M1A. We've seen this dance before. It's going to be M1A plus M1G. What was M1? 5 times 0.493. I'll use my answer button. Plus 5 times 9.8. .5 newtons. Oh, we decided M1G was the winner. Well, that was dumb of me. I was still thinking that... Thank you. Wow. That was terrible. Let's bring that back and get that answer stored back on my calculator. How about M1G minus tension equals M1A? Is that what you're saying? Sheesh. Recover, Mr. Dewick. M1G minus M1A equals tension. Tension equals 8. 8? No, 5, right? 5. Get my masses right. Times 9.8 minus 5 times 0.493. 5 times 9.8, take away 5 times answer button. How about 46.5? So pick your method, pick your strategy. If you're not sure who the winner is, guess. Or you can figure out what the two, because the tensions will cancel. Temporarily ignore friction. If there's two masses, it's going to come down to their gravitational components, either straight down, or if they're at angles, it'll be mg sine. Is this the last one? It is. Good. What's yucky about example 4, or what's different about example 4? Missing a mass. Missing a mass. If mass 1 has a mass of 8 kilograms, check, and it's accelerating upwards, they did tell me who the winner is then. The winner is mass 2. And if mu equals 0.12, and the angle is 28 degrees, by the way, if you haven't figured yet, I did this picture myself, but to fit all the numbers in is a pain in words, so that's why I tell you what they are in the paragraph above. I did do the picture, but then I hand wrote stuff on anyways. Okay. Find the tension and find mass 2. Gotcha. Suggestions? Oh. Label our forces, you say? So I have M1G tension. Okay. M2G. And there's going to be an M2G perpendicular and an M2G parallel, where the right angle is right there. There's going to be a normal force about that big. I'll call it normal force number 2 to go with mass number 2. Which way is mass 2 accelerating? Up the hill or down the hill? Got to be down the hill, so which way is friction? So I'm going to have tension and friction force 2. Now, normally I'd say who's winning. No, they told me who the winner is, and they even gave me the acceleration. In fact, what does part A want me to find? The tension. I'm going to go look at one mass. Which mass is going to be nicer to look at? I think I'm going to find the tension with mass, I can't even say it, with mass 1. And in this time, tension is the winner. Yes, I'm right this time. Woohoo! Tension minus M1G equals M1A. Tension is going to be M1A plus M1G. They gave me mass 1, 8. They gave me A, 2.1 plus 8 times 9.8. Can I do that in my head? 9.8 plus 2.1 is going to be 11.9. Yeah. 880, 952? No, I'm off by a decimal. 95.2? 95.2. Is that right? Yep. Carried a 0 in there for some reason. Exactly 95.2? Nothing else? Yeah? Okay. Newtons. Okay. B. What's B want me to find? Mass 2? I guess we better write an equation for mass 2. Looking at mass 2, who's winning? Okay. Who's losing? Looks like I have tension and friction. That equals M2A. This time, because we're only looking at one mass, the tension doesn't cancel. So, sorry, we've got some tension in our lives. M2G parallel minus tension minus mu times the norm. Oh, I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Right? M2G parallel, 2 lines. Minus tension minus mu M2G. Perpendicular. It's not 2 lines. It's not sine. So what is it? Of course it is. What are we trying to find? How many M2s are there? 3? Ugh. You know what? Let's get them all to the same side. So I'm going to minus this to that and plus this to that. I'm going to get negative tension, okay, drops down like a domino, equals M2A plus mu M2G cos minus M2G sine. Did I get everything? I think I did. How many masses are there? 3. How many would I prefer? 1. It'd be wonderful if there was some kind of grade 9 mathematical operation that I could factor, right? So the negative t drops down. I factor out an m2 from the first term, and an a will be left behind. A mu g cos will be left behind. A minus. And a g sine will be left behind. Okay, I won't say that it looks pretty. It's ugly. But how would I get m2 by itself? Divide by the bracket. So I think mass 2 is going to be the negative tension, all divided by a plus mu g cos theta minus g sine theta. Let's plug in numbers. Oh, that's why we had to find tension earlier. 95.2, negative 95.2, divided by, please tell me they told me A, it was 2.1. Plus mu. What's mu? I don't know. What's mu with you? 0.12. G. Cos. What was the angle? 28. Minus 9.8 sine 28. Whew. Negative 95.2. 2.1 plus 0.12 times 9.8 times cos 28. Take away 9.8 times sine 28. Close off the bottom. By the way, should I get a negative mass or a positive mass? Positive, it's kilogram. So I'm hoping that the bottom ends up being negative because the top is in my equation. And then do I get a 65.1 kilograms. Huh. So I'm hoping that might have helped with some of the questions you might have had from last day's lesson. If not, tomorrow, well, Wednesday. What? No, I guess I don't see you till Friday, because no school Wednesday. I will take questions on everything we've done so far this unit. For now, number 1. By the way, you'll notice it has mu k and mu s, but they're the same, so just treat it as one friction. We did talk about how technically there were 2 types, but whatever. 2 is a good little thought experiment. I didn't give you the answer, but you can kind of figure it out. 3, and I'm going to put a star next to 3. I think you can all handle it, but I'm going to tell you that's probably tougher than I'll ask you on a test. I will probably feel comfy asking you to find a mass, but asking you to find a mass, well, actually, no, they're frictionless. This is fair game. If I'd asked you to find a mass with 2 different angles and different frictions, that'd be overkill. I figure you can get it, but it's just such a long equation. 4? Nah. By the way, what I would do is I would actually break this 120 down into a perpendicular and a parallel component, and I think that angle and that angle are the same. I don't know if it's going to be sine and cosine the way the gravity is, though. I'd have to muck around with it. I could handle it, but that's overkill. 6 wants you to find the angle of theta. Nah. I like number 7. And 8.
How much do you want to
Yeah,
do
so
something?
much you.
I like number 7. I like number 7. I like number 7. What I like about it is I'll tell you, on your test, there is going to be a ramp. There is a ramp here. With friction, there is friction here. Where instead of saying find the acceleration or find the tension, I ask you something from Unit 1. How much time? Find a distance. Find V final. Find V initial or something like that. But, oh, really, you're going to spend most of your time finding the acceleration before you can do that. It's a good review. The water skier is tempting, but I'm going to pass. You know what? 10 is cool, so is 11, but I'm going to pause there, I think. That's a lot to practice along with the stuff from last day, and these take a while. There's no quick, short way to get through them. By the way, lesson 8 is just more obscure. We'll look at what we call the lawnmower problem, and we'll look at some equilibrium problems, but it's going to be nothing new. It's just going to be some kind of specific examples. So really, if you want to, technically right now, you can do every single question in the great big review if you wanted to start on the ultimate kinematics or dynamics review. Also remember the answer key is online. Okay.